An educative a day keeps unemployment away. Recording an educative a day might get you to the moon. So today we are day 27, I believe. We are reversing the nodes in even length groups. And now this problem statement is a bit weird. It's a lot. You probably have to read it more than once to get everything it's saying. But maybe the example might help us. So we have a linked list, and every even group, the groups increase as numbers increase. So the first element is a group, the next two elements are a group, the following three elements are a group, the following four elements are a group. So that's how we're grouping the linked list based on how numbers go, like they call them natural numbers from 1 to x, right? So x is infinity. So the first node is a group, the second is a group, the second two elements are a group, the next three elements are a group, the next four elements are a group, and so on. Like this is a group, these two are a group, the next three would be a group, and so on, like this. This is a group, two elements, the next three elements are a group, the next four elements are a group. And then the task is to reverse every even numbered group. So in this case, we reverse these two because there are two elements in their group. We reverse these four because there are four of them in the group. Here, we reverse these two. Now, ideally, there would be up to three in this group over here, but because there are only two elements, we go ahead and reverse it. So it's based on the number of elements in each group. Similarly here, this group of two is reversed, and this only has one element in it, so it's not reversed. And that's all there is to it, really, to the problem. So with that in mind, if we look at this quiz, how would this change? So we know that 4 is a group, 3 and 0 are a group, and they're going to be reversed. So 4, we have 0 and 3, but then we have these two, so we can't eliminate it yet. 5, 1, 2. 5, 1, and 2 are 3 elements, so they don't get reversed. Now, ideally, this might get reversed, but because they're only 3, they're not up to 4, they don't get reversed, so they stay the same. So it has to be this one, right? Because this one got reversed. And I hope that is clear, as clear as possible. I don't think this is very useful for understanding the solution. I feel you just want to look at it right now, which is what we're going to do. So this is how it works. We need some variables, as usual. Previous group length variable to keep track of the length of the group that we're evaluating. But let's jump between the code and this diagram to understand the solution to the problem. So this explains the different variables we're initializing. We have a previous pointer at the last node of the previous group because we're starting out with the second element, because again, this is an odd, the first element is an odd numbered element and cannot even be reversed. So we always start with a group length of 2, and then we keep track of the successfully traversed nodes in the current group by the variable number of nodes, so which is set to 0 as no nodes have been traversed. So this is our beginning state for this problem, and that corresponds to the code here. If you pay attention, we pass in the head of a linked list. We set previous because we're evaluating the second group to start, right? Previous starts out as the node immediately before the current group, as you can see here. Then the head doesn't need to be reversed since it's a group of one node. So we start the length at 2, group length. So group length starts out as 2. And it indicates the length of the current group because the current group that we're evaluating is here. Lastly, we keep track of the successfully traversed nodes in the current group by the variable number of nodes, which is set to 0 as no node is currently traversed. All right, so while previous.next is not null, this is our terminating condition for the whole loop, and it's the only while loop like that covers the whole problem. So while previous.next is not null, so while we're not at the end of the linked list, do this. set the node to previous, which is what we're doing here. Initialize number of nodes to 0. We've done that. Then we traverse the current group of nodes and increment number of nodes along the way. So that's what we're doing here. This block, this for loop right here, it does that for us. Let me see if I can make the fonts bigger. Okay. So graph this. We see we're here. So we're incrementing the group, traversing the current group of nodes and incrementing the number of nodes along the way. And that's what this is. While I is less than the group length, the current group length, we increment it. If it's at null, it means we're at the end of the list already, so break out of it. Otherwise, increment the number of nodes, move the node on to the next thing. And we do that till we reach here, the end, to group length of 2. Number of nodes is updated to 2. Next, well, in the code, we check if it's even or if it's odd or not. If it's odd, just move previous to where the node is. So if this was odd, we just move this previous tracker over here, but it's even, so that's not what we're doing. Instead, we have encountered a group that has an even length of nodes, and we want to set reverse to node.next. So that's what he's doing here. Reverse. Remember, node is here, so we're going to set reverse to node.next here, and we're going to set current to previous.next. So reverse is node.next. So after the window of what we're reversing, and right at the start of the window that we're going to reverse. Okay. Then we have this current.next variable. Next, we iterate for the number of nodes that we've confirmed. So for this number of nodes that we have confirmed, which is 2 in this case, we reverse and reattach basically. And this is the process. This loop does that for us in its entirety, and it's a bit confusing, but it's similar to is reversing a linked list with an extra step of reconnecting its entrance and exit. So we set current.next to what, remember current is here. Current.next is set here, and then this value, the current value, is set to its next pointer is set to reverse. It's super confusing at first, but if you run through it enough times, it sticks. And that's what this is doing. So we have this thing to hold this for now for us, and we set the next to reverse. So you can see current.next, instead of pointing to 6, we make it point to reverse, and we set reverse to current, and then current to the former current.next. So current will move to the right, but first it's gonna attach itself here. So 2, because 2 is the end, is gonna attach, because remember, this 2 and 6 is gonna become 6 and 2. So 2 needs to connect to 3, right? And we move this next. This is the next thing we're going to evaluate. And we move this back here to the reverse. Super confusing block of code, but you got to do what you got to do. So this now points at this. So we've reattached the end of the linked list. We have moved our current pointer here. Now we're gonna have to reverse what this is pointing to. This is a normal reverse linked list procedure. So this points over there. Current.next, we keep track of that. The same thing. we're still in this loop. Everything that's happening here is inside this loop. So this line of code is the super confusing part of the diagram that I was explaining. You see it here. It starts here. So current starts right here at previous.next at the start of where what we're gonna reverse. Reverse starts right after the node we're gonna reverse, and basically current is gonna move and be the thing that helps us reverse the order and reconnect things around. So we keep a track of current.next. We then connect current to reverse, like here. Keep track of current.next, then connect next to reverse, and then set reverse to what's current. Set current to what's current.next, and you see that here. Set current to what's current, and you do that in number of node times. So we've done it once. We're about to do it again, and so keep track of what's current.next. Set current point current to reverse. So keep track of what's current.next. Set what's after current to reverse. Set reverse to current, and then move current to current.next. Keep track of what's following current. Set current to .next to reverse. Set reverse to what's current, and then set current to what's currently current.next. That's all. So we've done it twice. So now we're breaking out of that loop. And once you've broken out of that, we keep track of what was previous.next, in which case is 2. We're keeping track of 2, previous.next. But in the meantime, setting previous.next to the node. So we're setting previous.next to the node. The node stopped at 6, if you remember. Right here, stopped at 6. So setting previous.next to where the node stopped, right? Setting previous.next to where the node stopped, and after moving previous to what's previous.next, which is 2, and then we have cleaned it up. This is what happens. By the time you get here, that's what happens. Then you increment the group length and do it again. Group length is now 3. So from here, count 3 steps. 1, 2, 3. It's even. Right? So it's not even. So we come over here and just set previous to node, which is what happens here. And then we do the same thing for this one. So group length is 4 this time, but we only have 2 items here. However, the number of nodes is in fact an even number. So we do the same procedure, which flips things around, and we're done. We're at the end of the list. We've hit the condition for the loop to break. One of the conditions, I think it's this one actually. No, not this one. It's probably this one. This condition right here. And time has gone for this video, but big O time complexity is O of n, because we only move through the loop once, and space complexity is O of 1, as usual. Thank you for watching. Quite confusing, so you can follow the code and rewatch the video as often as you want. All right, cheers.